The concept for EPARTRADE is basically, in my opinion, there's a big hole in the internet. So the internet started many years ago, but there's never been an online business community for racers on the World Wide Web. The need for EPARTRADE is actually quite obvious. Basically, people in the business of auto racing need a place online to hang out and to get their problems solved.
It's extremely simple for a buyer or for a supplier to interact on the platform. The first thing you need to do is sign in, which is free. And the second thing is, when you see a product that you're interested in, all you need to do is click on request more information. If it's a company, you click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
You can go to epartrade.com, you become part of a community of businesses in racing, and it makes sourcing products much easier than just on the internet or using Google.
At EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier through an email.
More than that, it's a place to go just to keep current every day. So it's a good place to start your workday in your racing business or in your offices of your professional race team. And you know you're current when it comes to new technology, industry news, technical papers, technical videos, all of that and more. We're not looking for a million hits per day. All we want is people who are really the volume buyers of racing products in the racing industry to be part of the little world of EPARTRADE. We have racing businesses participating from around the world. So you get suppliers from around the world, you get buyers from around the world.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Good morning and welcome to Race Industry Now, the technical and business webinar series from EPARTRADE, presented to you by ARP. I am Francisque Savignan, the founder and CEO of EPARTRADE, the global online platform for the performance and racing industry. And with me this morning is Judy Kidd, the co-founder of EPARTRADE, and Mr. Jeff Hammond, who is going to step in for Brad Gilly today. Good morning. How are you guys doing? Can you hear me, Jeff?
I'm doing well, thank you. And you know, Francis, we've had a really good week. We have confirmed for Race Industry Week Michael Shank, Michael Andretti, and also Emmett Hahn with the Chili Bowl.
Yeah,
so we are preparing, and it's looking good.
The week is going to be absolutely incredible. You know, from Andretti to Zach Brown to Doug Yates, you know, IMSA, Jim Campbell, GM Ford. I mean, it's just like, so who's who in the industry? So please join us. We have also a wonderful host, Jeff Hammond and Brad Giddy, going to be hosting a lot of those webinars. So the week of the 29th of November, Monday to Friday, back-to-back 5 days, 55 hours of webinars. And so this is going to be the second annual. Now, today, so thank you, Jeff, for stepping in. Brad had to be traveling to the NASCAR races, so Brad and Jeff alternate the hosting of webinars. So thank you very much, Jeff, for being with us today. We're going to travel to my own country. We're going to travel to France, and we are going to be bringing two gentlemen from a company called E-MERSIV that specialize in high-performance batteries for racing application. So I am getting a signal from a producer, Reed Keneski. We're going to have a double feature, correct, Judy, today?
Yes.
So first, the first hour, we're going to be talking with E-MERSIV. And then in 1 hour, we're going to be bringing some very special guests from the national, drag racing, the National Electric Drag Racing Association. And we're going to have be with them for about an hour. Good morning, gentlemen.
Good morning.
Good morning, American friends. How are you?
Good afternoon to you.
Yeah, thanks a lot.
Jeff Hammond, we'll let you take over.
Well, good morning, Francis and Judy, as well as gentlemen. Welcome. I am totally thrilled about what we're getting ready to talk about. It is, I've been reading some of the notes and everything, and you got to realize I'm old school. I'm so used to the idea of engines but today we get a chance to talk about motors and be the correct way. This race car has got a motor in it, because we all understand, or at least I do. My daddy taught me that engines make their own power. Motors, they require electricity, and this is exactly what we're going to get into: the future of racing as it pertains to electric cars. I mean, I think it's the wave of the future, and I'm really excited to hear what you guys are going to explain to me. Fortunately, I have watched some electric car races from Europe, and I've been around some cars here. As a matter of fact, from Team Penske, they've got pit stop cars that they run inside their shop that are electric powered. So, you know, take it away. I mean, really educate us and bring us up to speed and give us an idea of, you know, what's next.
Thank you for this introduction, Jeff. That's great. Let me just share my screen just to show you a few. No, I think. Can you actually see the screen now? Or is it coming up? Yes, is that okay?
It looks great. Looks great.
So yeah, I'll start with some introduction on who will be speaking today to you. I will let Arnaud to start with his presentation, and then I'll take over.
Yes. Hi, everyone. My name is Arnaud Derrant. I am CEO and co-founder of the company E-MERSIV. E-MERSIV develops high-performance battery packs. And yes, my background is that I used to work as an engine designer at PSA, which is now Stellantis, part of Stellantis Group. And I am the co-founder of EXOS, a company specialized in thermal management since 12 years now. I'm really excited to be here together with you, American friends. And yes, I think we're going to have some interesting discussions regarding the trends and in motorsports, especially for electrification. And I'm together with Maxime. So Maxime, please.
Thank you, Arnaud. So I'm Maxime Norgay. I've joined the company a few months ago, actually. I've done 10 years of experience in my career. So far, everything has been done in motorsport. So I've been working in LMP teams, in Cosworth, so all IC engines. And over the years, I've changed my mind on this, and started to join the electric racing, the electric motorsport industry with spark racing technology. So a pioneer in electric racing with the Formula E, providing some parts, so providing actually the Formula E cars. And a few months ago, as I said, I joined E-MERSIV just for carrying on developing such great technology that we try to showcase today. I'm not sure if that's clear enough. I mean, do you have any experience, and do you know what is the electric racing at the moment, Jeff, or is that something that we should cover today? We'll cover it then. So yeah, as electric racing isn't new. I mean, it might sound very futuristic, but actually started back in 2012. When you look at this quick graph, started back in Le Mans, with the Audi winning, the first Audi hybrid winning the 24 hours of Le Mans. So it's back in 2012. 2014 was a big milestone in the electric racing industry, with the first, the genesis of the Formula E. So the first EV, fully EV cars, EV racing or championship, actually backed by the FIA as well. So it's quite a big achievement. In the same year, the F1 became hybrid with some, we became hybrid in the same year. Nowadays, there's more and more races. Obviously, the races I mentioned in the championship still carrying on, either in hybrid form or in fully electric. But there's even more races with the Extreme E more recently, so SUV, big power, going everywhere in the world. A new championship, again backed by the FIA. And even in the next months, there will be again more races with the WRX coming fully electric. And for you guys in the US, you probably heard about the NASCAR and IndyCar looking at hybridization. So electrification, again, it's a thing happening, and it's happening now. Why? I would say a few words on why the manufacturers are joining this. As we know, the entire industry at the moment is shifting. The motorsport and the electric motorsport is a thing. The finance are driven for electrons. Everything, at least in Europe. I'm not sure if that's the case really in the US, but in Europe, when you see an advert for an automotive advert on TV, everything is about electric cars or hybrid cars. So this is a thing. And as usual, the big OEMs and the manufacturer are joining the racing industry and the racing championships for marketing platforms. So for sure, it's good for them to advertise that they are taking part of this championship. They are winning electric races. But as well, I mean, it's really all the essence and the heart of racing since its inception. It's to develop new technology and it's to use the racing as a lab. For sure, they are developing the next powertrain, the next generation of batteries and everything, you know, on the racing format and the racing championship, because it's the most extreme, it's the most severe conditions. And for sure, if you can withstand these extreme conditions, they will then extend that on everyday car, on everyone's car. So summarize, I mean, the manufacturer, there's a big interest at the moment in the future for sure for electric racing, just for this, for the marketing and for the technology, to develop the technology. So I'll talk a bit more on, I mean, electric and motorsport. As you know, as you've seen, they are compatible. How does it work? You might not be familiar with. I've got a quick video to show you about that's a first generation of Formula E car. So that's a single seater, or credit to Formula E on this. That's the first generation. We're actually to the third generation, but they all work kind of the same. So there's always a battery, the big black box that you can see, that is connected to an inverter that actually is driving a motor. So the technology, whatever the electric racing car is the same. So there's energy coming from the battery inside the inverter that is actually driving the motor. So the current is flowing from the battery to the motor through the inverter. So that gives traction to the car with as you have seen on the video. The outstanding feature for an electric car compared to an ICE car would be, first, you've got regenerative braking. So that means that instead of using your caliper and your pads, your standard braking system just to brake the car, you can actually use the motor to brake the car. And this will generate some power and regenerate some electricity, some energy inside the battery. So you can gain a bit of autonomy, of energy inside the battery just while it's braking. So that's a nice feature. And secondly, I will add, I mean, any driver that has jumped in a Formula E car, in electric racing car, they always are standing by the instant torque. That's the thing of electricity. I mean, jump in the car, just standing car, put your foot on the throttle pedal, and it accelerates instantly with a great acceleration. That's the instant torque that he's talking about. So it brings something new to the racing, to the electric racing. So, but there's few things. I mean, when designing a car, it's not that easy. I mean, from that picture, it looks very easy just to add a battery and an inverter and a motor together. But it's not that easy. There's a lot of compromises, a lot of estimation and simulation to be done before, just to avoid to make any mistake. So just the good criteria, or I'm not sure what to say, but to design a battery, you have to know how you will use it. How will you use your car? Will you use it on a racetrack? Will you use it on dirt, on mud, on gravel? Where will you use it? Will it be in Himalaya, anywhere is possible, but you have to define this very precisely at the beginning, because that's when you make mistake, and you don't want to make mistake at the beginning. For example, most of the time, you are giving and you are providing a power profile, which is basically how much power you want to pull, you want to regenerate from your battery on a certain conditions, over lap or over an entire race, how many times. So all these conditions, they have to be defined early on. From this, in the battery, well, one of the key topic of a battery, because we talk a bit more on this webinar about batteries, one of the key topic is that you know that when you pull power and when you regenerate power inside the battery, the cells, or where the energy is, they will heat up. You have to contain and to maintain this temperature within a certain level, just to make sure that the battery performs as its best and its optimum. So here's a quick example, a quick draft of a simulation that we've done for a customer, where actually when designing, when taking only the data sheet of the component, if you take only the data sheets, it will not work. You have to know everything, because for example, here we did simulate the cell temperature, and you can see that there is a limit to not to exceed, not to exceed, sorry. This limit was actually reached in less than 1 minute. So all these criteria, all these everything has to be taken in account, because if you go over that limit, so either you will lose performance because you try to stay at the limit, but then you'll have to derate, what we call derating the powertrain, so you have less performance. Clearly, it's a no-brainer. It's no go for racing, because you always want to go fast and you always want to have the maximum power from your car. Or actually, I mean, if you go over the spec in the temperature spec, for example, for a cell, you've got a big risk of fire. The cell can actually take fire. This fire can expand to all the adjacent cell, all the other cell and everything, and then you end up with a battery in fire. So everything has to be maintained, has to be controlled, has to be designed and defined well ahead. And it's not that easy to just add some cell together. I've talked about cells. What is actually a battery? Here again is the first generation of Formula E battery. So credit to Formula E, but it's a battery is again pretty much always the same. So they are cells, so they are the energy storage. They are connected together electrically through metallical part, which we call bus bar. So they are through this bus bar, the current is flowing, and it enables you to have some traction to the car. As I mentioned, the cooling of the battery is very important. We'll come back on this topic a bit more later on, but you have to keep the overall battery temperature within a certain level. So for sure, you have to maintain and you have to design it at the beginning of the project. And yeah, so that's one part. And then you have to hold everything together. So inside the battery frame. So at the end of the day, the battery looks like a big black box for you, but inside there's a lot of technology. There's a lot of areas of development. This is an example of the first Formula E battery, but the figures were already outstanding for the year it began. So it's 800 volts. That was 200 kilowatt for about 200 kilos, and the number of cells, for example, on that battery was around 200. But depending on the shape and on what way you do, you can go to 3,000. I mean, it depends really on the use case that you want to do with your battery. Talking a bit more about the cells as well, you have to know how you want to use and what you want to do with your car. It's very important because there are different kind of cells. I'm not talking about chemistry. There's even other aspect that I won't explore here. We'll try to stay focused on the cells, but there are, for example, three very big form factors. They all got their pros and cons, all got advantages. There are the cylindrical, the prismatical, the pouch cells. Some like the cylindrical, they will be more used in a racing environment because they are smaller, so they are easy to adapt to any shape of the battery. You can design a battery around a car. It's much easier. Where the prismatic, for example, and the cylindrical will be easier to source probably. So that's when you need something fast and something very efficient, and as the racing hurt is, then you will go for cylindrical. But then the prismatic will offer other advantages, such as the fast charging. For example, if you want the battery to charge in less than 10 minutes, maybe the prismatic will be the choice that you have to make, or the pouch will be more for production, or it's a greater energy density. I mean, there's a lot of advantage again. One technology to the other, you have to choose, and you have to know very well. It's not that easy to design a battery at the beginning. When you know how you want to use your battery, or you want to use your car, then you can make the proper choices depending on that. We talked about the heart, the cells, so which are really again the heart of the battery. We can talk as well about the brain of the battery. There's another key topic is this brain that we bring what we call a BMS, a battery management system. So all the cells, they are monitored every 10 milliseconds, 1 millisecond. There's a lot of instrumentation, a lot of sensors, everything just to make your car and your battery the most efficient possible, but as well, and most importantly, the safest possible. So how does a BMS works? So there's most of the time a master BMS and some slave BMSs. Depending on your configuration, you can have up to 12, 16 slave BMSs. The BMSs, the slave BMSs, they are measuring the voltage and temperature of each cell, and then they're communicating this to the master BMS. The master BMS will be the brain of the battery. So that's where the intelligence, where the communication with the rest of the car, the monitoring is done. So for example, it will monitor live how safe is the battery? Is there good isolation? Can you touch the car nicely? Is there no problem? Or is the battery overheating actually? If the battery is overheating, maybe we'll allow the car to pull less power, to regenerate less power from the car. But as well, we give some information on its health, just the SOC, so the state of charge. Is that fully charged? Can you still, do you still some range to do or to go? It's really, really the brain, and this has to be taken. I mean, it's not only just some cells added together again, once more. When you design a battery, you have to take care of this. What is my use case? How I want to use my car, what I want to use my battery. So what kind of cells should I choose? How should I monitor them? How can I make my battery safe as well? So this is just talking on the battery, but there are still plenty. There have been, and there is still plenty of improvement to be made on the batteries. I will probably leave Arno to speak a bit more on this improvement that have been done in the past and are still being done now. So Arno, if you want to take over.
Yeah, sure. So yeah, if you can just have a look on the power and energy density that has changed in Formula E. You can see in the video that at the early beginning, the Gen 1 Formula E, the pilot have to change the car because the energy that was contained in the battery for a given volume was too low, and it was authorized at that time only 20-minute race. And now, after 8 years of development with a similar weight and similar volumes, they have doubled the power from 150 kilowatts to 300 kilowatts, and they have multiplied by 2.5 the race time that they can do, so the energy that is contained inside the battery. So you can see that there are a lot of improvements being done in the race industry for battery in only 8 years. Power multiplied by 2, and let's say range of the car multiplied by 2.5, and there are still room of improvement for your race and for your vehicles. But more and more power and more energy leads to higher heat to be removed from the car. And here we come to the several cooling systems that exist for cooling the batteries. So you can see, basically, there are 3 main cooling types from the air cooling. Air cooling is just that you blow air on the cells. And then you have the liquid cooled cold plates. That means that you have an external cold plate in which you have a fresh liquid, water glycol, that circulates to cool the battery, but it is external, so not in direct contact with the cells and the busbar. That are the things to be cooled. And then you have our technology, so it's called immersion cooling, which is 3 to 10 times best than the best cold plates. And what does it provide to you? It provides a continuous power to energy ratio that is higher than 5. That means that if you have let's take a simple example. If you have a 100 kilowatt hour battery, you can get 500 kilowatts out from this 100 kilowatt hour battery. So 5 times the energy, the power equals 5 times the energy. And you can see that the heat transfer coefficient, which is just the image of the capacity of the cooling system to remove the heat from the inside of the battery to the outside of the battery, is far higher. It is 10 times more important than air-cooled, and approx 3 times more efficient than cold plates. So if you want the best performance, you need to cool your batteries, and we call it keep it cool to keep it efficient. That's the way we present it, and this is what we provide. So maybe next slide, Maxime. Thanks a lot. So let's have a deeper look in the technology in detail. So the immersive technology. So we use immersion cooling. You can see on the left side that there is a liquid inside the battery. So directly, this liquid is called a dielectric liquid. Naturally, this is a non-conductive liquid. And this is a thermal liquid, thermal non-conductive liquid to be exact. And this liquid is inside the battery. You enter the battery as a fresh liquid. And the advantage of it is that you have the cells at the average cell temperature, so the delta the delta temperature between the hottest and the coolest cells is really well controlled thanks to our system and cooling system. And you can also monitor the highest temperature that your cell never need to exceed or will never exceed. I mean, for example, most of the cells are limited to 50, 55, 60 degrees Celsius, and that you can monitor it thanks to this system. How do we do that? We have an EBTMS in our case, so it means battery thermal management system. So normally a BMS, battery management system, is here to control the safety and the charging strategy, as Maxime already explained. In our case, it controls also the cooling loop, which is brand new. And we couple this both innovation with advanced algorithm to get the best performance out of a battery pack. And so this leads to smaller batteries with higher performances. Okay, maybe next slide, Maxime, thanks for that. So this is, as vehicle manufacturers, some of you are vehicle manufacturers, you will need to integrate this technology inside your vehicles. And these are examples on how to integrate a battery pack inside a vehicle. Here, the image is for flat battery pack for an EV car, but you can imagine to have a U shape or T shape where the battery can be integrated inside a tunnel. We have a modular approach, so we can stack the modules in horizontal or vertical direction. No problem for that. It depends on the constraints of the vehicles, naturally, and the energy you want and you need to embed for your race. And then the cooling loop is simply a cooling loop. So you have in the front of the car a front radiator, and then you have pumps, you have pipes, just like a normal cooling loop inside the vehicle. We have several patents on that, and naturally we act on two things. The way the complete system is being controlled to ensure the best performances and safety. This is also key in the race industry. You can have crashes. This happens often, and then you need, or we need as a battery pack provider, to ensure the maximum safety to our customers. And thanks to this immersion cooling technology, as the cells are submerged inside the liquid, if a cell catches fire, it does not propagate to other cells. So doing so, we provide key integration features to provide the best weight or the best performance overweight ratio that is, yes, in the industry for battery packs. Okay, can go, yes. So just a few words on our company E-MERSIV that develops submerged high-performance battery packs. So just have a look on that. So we provide, as Maxime explained, everything begins with battery sizing. And this is really important. Each race, each vehicle, each cycles needs a proper adaptation. And so this is our core expertise to size correctly a battery, to choose the right cell, and to provide you with the best performance and safety ratio. And then we develop everything in-house from the battery, naturally, the modules. So we buy the cells, stack them into module, and then assemble the module into a battery pack. But we also provide the high voltage battery management system. We do the tests internally, and we manufacture our own batteries. And depending on your needs, you can focus on charging time. So we have applications and cells that are well dedicated for fast charging. So in that case, we put under 10 minutes for a 20 to 80% charging time. But we can have with custom cells, or if you look at from 20 to 50%, for example, charging, we can reach better performances like 2 or 3 minutes charging time. Then you might be looking for high power to energy ratio factor, and this is also what we can provide. We can provide very high ratio because we completely master the cooling loop and the heating of the cells, and we maintain the cell temperature and the delta of temperature between the hottest and the coolest cells in the right range that is compliant with the datasheet, and also that provides you with the best performance. And then we have safer batteries than competitors because we have no fire, thanks to our liquid that acts simply like fire extinguisher liquids. So if a cell catches fire, then it cannot propagate to other cells. So this is what we provide at Immersive. Then let's have a look to your projects or your needs maybe in the future. So if you wish to develop a hybrid or full electric vehicle in 2023, we should begin to talk as soon as possible, because there are plenty of steps before providing you with a high performance battery that is really dedicated to your needs. First, we need a lot of exchanges regarding the definition of your needs, and don't be scared by that. We have all the tools to help you to fill a lot of Excel sheets and let's call them technical requirements. So we have a lot of habits for that. And then we do the design and testing. We can also act as advisor for the choice of e-motors and converters or DC-DC machines, naturally. Then there is the vehicle integration. So we will need to put the battery pack inside the vehicle, and then all the tests to be done on the track. So this generally represents between 18 and 24 or even 36 months, depending on the complexity of your project and your needs and the number of cars to be equipped and so on. So yeah, if you wish to have a project in 2 or 3 years from now, we should begin to talk as soon as possible. And we are really happy to have this opportunity with our American friends. Next slide, please. Okay, so the thing that we'd like you to keep in mind and to take away from our presentation is that we do believe that motorsport will change, and electrification is a must. And we see it in Europe, in Asia as well, and maybe we will see it more and more in the US. And the reasons were explained by Maxime. Yeah, we see that the major brands that are pushing electrification or that are forced due to CO2 emission regulation to provide BEVs, battery electric vehicle, to their customers. Now they want to put money on electrified motorsports because it's a marketing platform as well as a lab to develop their new technology. So we do believe that electrification is a must. It's no more the future, it's the present. Working together to be ready for tomorrow, as said, yes, it's generally 18 to 24 months for this type of projects. And you're going to have all my contacts in the next slide. So you can keep that contact and maybe ask EPARTRADE if you don't have time to, to write it down. But do not hesitate to ask them and to contact us, whatever, by phone, by email, or directly on our website. We are really happy to help you on your projects, electrification for racing projects. And yes, we are now here to answer to your question together with Maxime. Maybe Jeff, you want to also add a word on the presentation that we just gave.
Well, thank you very much. Very interesting, guys. And again, I was being quiet because I felt like I had printed out your presentation today and had been reading through it and kind of keeping up with it on paper along with what you're doing here. And it brings to me, being a NASCAR guy, obviously we have been, forewarned through the folks at NASCAR that we will be working, toward an electric race car in NASCAR's future. So that's a thought process. And at the same time, I've got a question as far as what is the horsepower to weight ratio when you take a look at one of our big bulky stock cars that we're racing here in the United States, and then I look at what you're currently racing Formula One and E and the other Le Mans type series that you're racing currently in Europe. How does that compare? And at the same time, if we've got heavier vehicles, what can we expect, and where's going to be the plus and minus on that scenario? And is a max as far as speed that we could be expecting, acceleration and everything like that? I know acceleration is not a problem with an electric car. I've already seen that. I know that a few years ago, or at least I know it's been many years ago, I should say, Ferrari had that combination battery engine driven car that set world records because it would launch incredibly fast and then change over to one of their normal aspirated engines. So the future is there. So have you looked at NASCAR, and what can we expect as far as your company and their involvement?
Sure, I know you want to take it, or
Well, I think it's more, a technical question regarding the vehicle. So maybe you can take it.
For sure, at the moment, as you understood, the acceleration and torque, the instant torque is the key factor for electric racing. Obviously, there are some limits still. I mean, as we mentioned in the presentation, the technology is evolving very quickly, but it's not mature. I mean, it's mature, but there's still some areas of improvement. With that technology of battery, you will be able to have a smaller battery for getting. I know that NASCAR, the power is king. I mean, power is king. You need more power to get that much power. We are bringing a new technology that will enable you to have a smaller battery. A smaller battery not only means a smaller size, but obviously smaller weight. So all these factors, when you take them in account, you will be. You see the figure. You've seen the figures how much it evolved. So for sure, if we start to work now for NASCAR, it can bring a lot of entertainment and a lot of acceleration at the beginning, but even we can push the technology, and we are pushing the sales and the technology further and further for this. I'm sure that will bring a lot of excitement to the races.
We got several questions here, guys. I don't know if you can see them, but we'll bring some of them up to your attention. Ron McCoy, seen a difference in fast charging versus slow charging?
The difference, the name speaks by itself. I mean, the fast charging, you will be able to charge your car in 10 minutes from 20 to 80%. So the battery is almost empty, and then you charge it in less than 10 minutes to get it to a state of charge, which is more 80-85%. So it's pretty much full. Which is a big way forward for the technology. Before, when you're talking Formula E, it's called a slow charging. So far, it was called slow charging. The battery would take an hour and a half, or an hour to charge fully. So basically, you enable, for a racing perspective, you enable either not yet pit stop, but you can see that the technology is getting there. Some probably in the near future you'll have pit stop that will enable you to fast charge your battery and to go again, or even some races like rallycross, they will go for an immersion technology, and that will enable them to have a lot of races within the day, because they are very short races, but you need to have 6, 7, 8 races within the same day. So obviously you can't spend 1 hour and a half charging your car between two heats and two races. So the figures to remember are probably an hour and a half before for charging battery compared to 10 minutes to charge it from 20 to 80%. That's the figure we're talking about.
Yes, and we see more and more championship increasing their power, their charging power. Like the Formula E next generation will be 600 kilowatts instead of 150. I think it was in the past. And 600 kilowatts for 30 seconds, and then you have the FIA EGT Future Championship that will charge at 700 kilowatts, which is enormous. Also for less than 1 minute, but with this very high power charging station, then you can get probably 20 to 30% in less than 1 minute. So this is also quite impressive, and we can imagine races for which maybe we don't charge at 80%, but we discharge the battery at 20% and then charge again for another 30-40%, but in less than 1 minute, just to yes, enlarge or increase the time of the race. Yeah.
And John Evans is wondering, does the immersion have any hazardous properties?
No, sure. This is one of our main concerns. We work in an industry that is tending to be to have less environmental impacts, and so we have lots of criteria to select the fluid, and they have for sure no hazardous properties, neither on the human beings nor on the environments, and this is really key. And just to mention that we already have two fluid makers that are US-based company, even though we already have also other companies based in Europe for providing this type of fluids. And now I think the fluid maturity is already obtained to have for sure non-hazardous fluids with very high performance.
And Ed, Art would like to know, do you see racing classes using the same size battery and type of battery packs within the cars to keep racing classes equal? You know, maybe similar to like an IROC type series.
Sorry, I missed a bit the question. I'm not sure if you got it, Arno, but that's basically.
Please, Jeff.
You want me to repeat it? I'll be glad to repeat it.
Yes, please, Jeff. Sorry for that.
Okay, no problem. He said, do you see race classes using the same size of battery and battery packs within the car to keep the racing class equal? You know, maybe to a similar type series.
Yeah, I mean, that's the whole essence of Formula E. I'm not sure if that answered the question, but Formula E, the battery packs, they are all equal within the cars. That's basically any team that competes has been provided with the battery, which is the same, just to keep everything equal. It depends on the championship at the beginning. I mean, sometimes the battery will be open just for getting the technology and getting more and more technology, or sometimes just for getting the equity between the competitors. Then the same battery will be used by everyone.
Well, and Frank wants to know, how do you envision the full EV races of longer duration? For example, the 24-hour races. Would you swap batteries during pit stops, or what would be the recommendation there, or what do you foresee?
Yeah, at the moment there are some championships that are going the way of changing the battery quickly. But for example, obviously one day there will come that the battery with fast charge and everything, with the technology that is brought onto the market, will be able to withstand a 24-hour race. So when is hard question. You see that evolves very quickly. I would say, I don't know, in 10 years time maybe, or I'm not sure exactly, but for sure that will happen, and sooner than we expect.
So, as far as I know, that there's some people playing around with solar panels when it comes to charging operator electric cars currently, and other types of motor driven engines. As far as that's concerned, I've seen some folks talking about trying to put electric engines in track, for example, and stuff that could be used on construction sites, et cetera, et cetera. Do you feel like that's something that is in the future?
Yeah, sure. Infrastructure will need to be taken into account, and a charging station for the racing tracks will be integrated more and more at the circuit level. And you're right, they will need probably solar panels, or wind turbines, or even let's say hydrogen fuel cell generation, genset generators. Yeah.
In Extreme, for example, the charging station has been taken in account, and this is done by fuel cell. So this is
sure.
clearly an area that, yeah, needs development, but is developing at the same time.
Yeah, and this very large charger will probably embed batteries as well to decrease the power needed from the electrical grid. So you will charge the battery of the chargers during night, for example, and then during the race you will discharge the battery inside of the batteries with the help of the electrical grid. So yes, this is a complete infrastructure that needs to be rethink, and I think we are going in this direction.
When we're looking and doing a comparison to type of race cars that you're trying to basically be put into, let's say Le Mans currently, when you take the weight of the engine as well as the batteries or the motor that you have compared to an engine and with fuel cells and fluids and stuff like that, how does that compare out? I mean, battery pack and everything, is it a lighter total unit, or is it about the same?
It's getting there. It's still behavior, but yeah, for sure. I mean, compared to an ICE car, the biggest disadvantage, I would say, of a battery, that's frankly, is that when you empty your tank, then your car gets lighter. But it doesn't happen with a battery. But for sure, at the beginning, as we mentioned in the slide with the evolution of Formula E batteries, at the beginning the battery was quite heavy compared to the size and to a normal fuel tank. But the technology managed to keep that weight down and down and down. And again, that's an area of development. At the moment, it's hard to say. It depends on your application, on the power, on the energy that you need. But it's quite comparable. A motor is probably weighing 20 kilos. So it's it's heavy, but it's clearly nowadays it's comparable weight compared to an IC engine, an IC system, I would say.
Yeah, I think the only thing that is not comparable today is the energy embedded. So that means that with a fuel tank, you can run hours, and with a battery, you can run for several tens of minutes. So there is still a difference here for sure.
We've got so many questions right now from Greg and Rich and Keith and everybody, and a lot of it is directed, at the batteries. What's the upcoming future for the batteries? I've got a question of, as far as the longevity of the batteries as well as the motor itself. I mean, how does that compare cost-wise?
Well, the longevity of the battery for sure is a key topic for us as well, and that's why having what we talked about, the BMS, and maintaining the cells within the right temperature and all this technology that helps you to get a battery for a long time. Just at the beginning, again, the cells were degrading very quickly because we didn't have the experience and the feedback from the racing environment on how to use the cells. Where now, I mean, we know the products, we know the cells, we know how to use them, we know the limits of the cells. Thanks to BMS, for example, we monitor them 100 times a second. So that keeps the battery very healthy for a very long time. Everything depends on your usage, but for sure we can guarantee that the battery will be can do for a racing environment. It can do years of racing. For Formula E, it's 3, 4 years, 4, 5 years with the same battery, with the same cells. So it's clearly a key topic for us in the development.
Yeah, and this is an entry point for the book of specifications from the technical requirements. It will be what is the longevity of the battery that is required by our customers, and this is something that we can design and choose by these constraints, I would say. So clearly, this is something where where the industry and the technologists improved a lot in the last 10 years. And now they confirm that what Maxime just mentioned, we are here. We are capable of designing batteries for years. Yeah.
And also, and again, talking about all the different series that you're involved with right now, how about the Extreme E series? I mean, how do you What do you have to do there that's different in that series as far as the heat and the dust, etc.?
As any race, as any championship, as any new development, you have to rethink everything on the battery. So maybe the kind of cell that we use, I'm not saying anything on Extreme or Formula E, but it starts from the cell choice. So for sure, you cannot take a battery that is designed for Formula E and expect it to well behave in Extreme. The power is different. Extreme would be 4-wheel drive compared to two-wheel drive in Formula E. The conditions, the CV conditions are clearly not the same in Formula E, in the dust, in the Arctic or whatever. So for sure you have to rethink everything. It's a complete new development where with a complete new specification at the beginning.
And Ron would like to know, will the batteries be recyclable, rebuildable to be able to keep them environmentally friendly?
That's a very good question regarding the fluid. Yeah, we are taking that into account as mentioned. So the fluid needs to be environmental friendly, which means either biosourced, biodegradable, or fully recyclable. So we have those three choices possible. And then regarding the rest, the cells and the rest of the battery, it's like any kind of batteries. So we buy cells from cell suppliers. So it is linked to the cell supplier recyclability, and then the rest is just metal, so metal and plastics, I would say. So it's basically, the rest is basically like any other type of batteries. The only difference we bring in terms of environmental impact is that we bring a fluid inside the battery, but as mentioned, this fluid is already chosen to be environmental friendly. So the rest of recyclability and so on, we can just add that thanks to our let's say cooling system, we can improve the lifetime of the battery for a given solicitation, for a given cycle. If you take a cycle and if you have a battery cooled by air, our will last longer thanks to immersion cooling. This is for sure. So this is already an answer that, okay, our battery will last longer, so the environmental impact will be lower.
With all the different Le Mans Hybrid and Extreme E, and as you have already started looking at, from 2022 on NASCAR and things, where can we expect the next series to come from? I mean, are you guys working with anybody, including, motorcycles or anything else? I mean, are there other series that are looking at what's going to be the future? What's going to be the next, basically, to fall in the racing world?
Yeah, I think the GT will be the next things. Maybe you've seen Porsche announcements at the IAA last month with Mission Air prototype, so still a prototype presented, but they clearly want to sell this car maybe in 2024 or 2025, or around that period. So yes, we do believe that all the GT races will be electrified in the near future, either hybrid or full electric. Yeah.
And one other safety issue have at this point in time is the batteries the biggest problem as far as safety concern and fires and onboard fires?
Yeah, it is the biggest problem and the biggest solution as well, as we mentioned. For sure, where the fire can start, or where is the most likely to expand and to be the most harmful is the battery. But again, it's where all the technology has been brought just to keep that safe, because we know, as Arno mentioned during the presentation, racing, there will be some crashes, there will be some heavy duty usage. So for sure, this has been thought since the beginning, and that's why I think, in my opinion, an electric racing car is safer than an ICE.
Can you share a little bit of the experience of being around some of the test sessions and race cars that have raced electrified? What is the response from people like Jenson Button as far as the driver is concerned? Are they surprised at the quickness of the vehicle?
Yeah, they are very surprised with the acceleration, as I mentioned. I mean, it's always the outstanding point. As soon as they jump in the car, they don't really know what to expect. The two key points are the acceleration, the instant torque. This is a really outstanding. Yeah, I mean, all the drivers jump out of the when they jump out of the car, they say, "Wow, that's fast, that's fun, that's fun to drive." And then the noise is a key difference. They are used even when the car is standing. There's they used to the ICE noise of a motor, and then with an electric car you don't get this noise, so it's quite new. I mean, they need to get used to that. But as soon as yeah, any driver, any even experienced driver as Jenson Button or any other, they get used to that, and yeah, it's great fun. It's completely different to what they used to.
Well, I know this, I'm sitting there thinking when you say that, the sound is probably one thing is probably the most challenging for me because I'm so used to hearing the roar of the engine. But you take it one step further in the line of competition. A lot of race car drivers realize, I got a guy inside of me, outside of me, because I can hear him, I can feel him. And today, I guess this would be one of the things that has to be a big learning curve for those who have grown up in a noisy world.
Yeah, it is a learning curve, but I mean, it brings some advantages. A driver in an ICE car, in a petrol car, you won't be able to hear these tires squeezing or how to feel the limits of the car. Where in an electric car, you might feel that even better, and you might be able to push the car even further, even to the maximum, thanks to that. So everyone needs to get used to, because that will happen, but there is some advantages on this.
And regarding some business case, it's also interesting to see that some circuits that are forbidden to have races during the night or after some late hours, I would say, will be authorized with electric racing. So you can also imagine new type of championship inside the cities, like the Formula E is just proving it's inside the cities, which is not the case anymore for ICS. So it also brings some new opportunities. But you're right, sounds is really linked to the racing entire industry. This is a challenge, but this will come, and mentality and new generation are also bringing this new world. You can see that, for example, the extreme teams. You have Jenson Button, but not only. You have Nico Rosberg, you have Lewis Hamilton, and all of these drivers. They are 30, 35 years old. They also want to send a clear message that they are conscious about their environments, and this will come more and more with new generations also.
Well, gentlemen, it's been a pleasure. I mean, it's been very informative, and it gives everybody like a general overview of it is coming. It's coming fast, and each day you guys are making progress, and you see the competition is getting keener, or especially over in Europe. And I know that it's going to be coming to the United States in a big way, because we've been warned. It's just right around the corner, and we already got people working on it just like yourselves. Really, thank you very much. And with a couple minutes we got left, if you have anything else you'd like to share with our attendees, just fire away.
Thank you for the opportunity for us to showcase our technology, and it was very great to speak to you and to touch the US market.
Yes, and we'll be really happy to have meetings with you, US people. Yes, naturally, we are all looking at the COVID situation and hope we'll be be able to travel soon in your country and have a lot of meetings and exchange about this electrification in racing, because this is what we like to do, also to get to bring support and also to have this exciting exchange on how this motorsports world will change in the coming years.
Well, thank you very much. What a great session, and so I know it's a new things, in the US, but around the world as well. It's still the amount of electric car racing is still very tiny compared to the overall, and growing. And I very much enjoyed this presentation today, because it reminded me 20-something years ago, when I first moved to the US, and NASCAR, Jeff was big crew chief, and won several championships. NASCAR was running carburetors, and everything was about, you know, engine management system and EFI in Europe and around the world, and change evolved. And so there is a real globalization in the industry, and that's a very important thing. So you have technology coming here. You have US, yesterday, you know, talking with the people from Penske Shocks, so US suppliers of suspension, who is a big partner of us. They are developing suspension for Formula One right now. So it's a global market, and it's a global sport, and it's very interesting to see different trends going, you know, there and there. And actually, our next session is going to be with a racing sanctioning organization that is, you know, very drag racing in the US compared to Europe is a huge market. It's almost a third of the racing population, and it's, you know, they're starting to go electric. So it's going to be a fascinating session next, and a great transition.
Registering on EPARTRADE is easy. Fill out your name, email, phone number, and create a secure password. Next, select your business type. Choose supplier if you're looking to display products or services and connect with buyers. Choose racing business if you're looking to find new parts and connect with suppliers. Choose race team if you own or are a member of a professional racing team. Begin typing your company name. We most likely already have your company in our database, which you can select from the drop-down. Then, enter your job title. Choose Claim Company if you'll be editing your company profile. Other members of your company can choose Join Company if they'd like to use EPARTRADE as well. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Click Register Now, and your registration will be submitted for approval. You'll need to confirm your email once it goes through. To keep our platform industry only, you'll be approved shortly after. If we require additional proof of business, we'll reach out. Welcome to EPARTRADE.